Hello. I think. Anyone out there? Morning, evening, afternoon, etc., etc. Wherever you are, whatever time zone you're in, I hope you're all having a pleasant Sunday. And we're back with some more CPP. Rand, Daz, Connor, hello, hello. Julian? It could be a Monday, it's true. For me, it's Sunday. I will ignore that, because I'll get banned from Twitch. But good one. Okay, so so gotta stay strong. Sunday is a bold day to start. What about the Sunday roast? What did you do in lieu of? Okay, wait for some people to roll in, and then we're going to do some coroutines today. This is, I will admit, slightly self-indulgent. We don't need coroutines for this project, but I kind of want to do them. So I think fun, bit of Mon C++, get ourselves the end goal is a game loop which gives us quite fine-grained control over how we schedule tasks, either on specific frames, so you can be like, please resume me in 2 frames, or 1 frame, or 3 frames, or in, say, I don't know, a certain amount of time, please resume me in 100 milliseconds. The idea being then that we should be able to run the game full speed, put the render in there, have that run full speed, and then anything else that needs like a fixed time or whatever, it can just schedule itself using the coroutines at whatever cadence it wants. Well, this is it. I think we should get both, so that should be fine. Okay, so let's quick reminder of where we're at. So this is the release as it stands, which you can download now on the GitHub. Queco, hello. No, so this is purely going to be single-threaded. So coroutines and threads are kind of orthogonal concepts. You can combine them, but I'm not planning on doing it for this. The idea is this is just how to best run. It's effectively just managing callbacks, kind of, on a single thread. What you'll see is, with the vision that I have for this, is that in theory you could have multiple schedulers across multiple threads, and there is nothing in C++ that stops you resuming a coroutine on a separate thread that creates it. So you could end up in a situation where you have multiple threads and you can fan out tasks and it all kind of just works. I'm not planning on doing that for this because I don't think we need it. Also, correct me if I'm wrong, I believe OpenGL has some stipulation that it must always be running on the main thread anyway, so, and nothing else has any considerations for multi-threading, so I think just to kind of slap some threads in there at this point would not be right. It's more just a way of managing the tasks. Yeah, I'm a big fan of reflection. I cannot wait for it to land somewhere where I can kind of use it. I'm gonna absolutely reflect the shit out of things. It's gonna be good. If we're still writing this game and reflection lands in MSVC, which I doubt, then I'd be tempted to go back and reflect all the Lua bindings out. I doubt single threading is common in modern games, because if you're not using all the cores and you're kind of just leaving performance on the table, I just don't think I'm doing anything that is so performance critical that I would need to use multiple threads. I don't know, we'll see, but this opens up that opportunity. Okay, so we all saw the game, we're all happy with that. Okay, let's start off with, yeah, and I would consider this a tiny game, a micro game, if you will. I'm going to start off with basically kind of hello coroutine, like the most basic coroutine you can write, and then we'll just build up from there into more and more abstractions until it's something useful, because if anyone has done C++ coroutines before, the syntax is quite obtuse, even for C++. Even for C++, I'd say it is a little bit obtuse, and that's come from someone who likes to write ranges. Okay, so let's start off with some tests, because I think I want to test this all out anyway, so I think we can use the test, again, an advantage of writing new tests. It gives us kind of a nice self-contained playground to work with, and then we'll just slowly roll it out. My plan is to kind of do most of the boilerplate this stream, hopefully, fingers crossed, who knows. Maybe tie it up in the next stream and then spend one stream integrating it into the game. So I'm hoping 2 to 3 streams. That's all I really want to... I kind of want to be done with this by next Sunday. So let's do coro tests, because I can't bother to keep writing coroutines. Coroutines or schedule. I think we'll go... I think I'm going to go scheduler. Because ultimately that's what we're going to be writing as a job scheduler. So we'll start off with that. gtest/ gtest tests scheduler simple assert true false. Again, my go-to way of starting off a unit test is to write a failing one, just so I can convince myself it's all integrated. I'm going to spell this wrong at least once. I might even treat myself to twice. Indeed, bingo cards done. What we're doing, we're going to write a C++ coroutine-based job scheduler for our game. And apologies to any Americans out there, we'll be scheduling, not scheduling. Just the way the cookie crumbles. CMake build config debug. Indeed, we must first fail, and I expect to fail a lot, because this is kind of annoying. Annoying? Yes, okay, fine, annoying. Well, this is annoying because this has already stopped working. Indeed. Okay, let's build this, get this running, and then we will do gtest I did have a little look at, so off stream there's C++ coroutines have a habit of memory leaking if you're not super careful with it. So I spent a little bit of time off stream trying to figure out how to integrate fsan and or the CRT debug, the leak detector, and failed miserably both and gave up. So I reverted all those changes, and we're just going to have to hope that we catch some memory leaks ourselves. I'm sure it's possible, I just kind of ran out of time, and I don't want to spend time on the stream doing it because it's just mechanics. Good. Oh, it's not even called that, is it? It's not shed. Okay, boom, right, we're in business. So I'm just going to write like a simple coroutine, and we'll go from there. So for anyone who doesn't know, a coroutine is just a function which you can suspend and resume the execution of. So if you think of a regular function, or sometimes called a subroutine, it executes once you start until it hits a return, and off you go. A coroutine will execute until it either returns or it hits like a special suspension point, at which point you return to the caller and you keep executing, and then you can resume that later on. So all functions are effectively coroutines. Coroutines is a superset, right? All functions are coroutines that just don't suspend themselves. So let's do auto foo void. So the most simple the most simple coroutine in the world is one that just returns value. Yeah, so you can you can yield, or you can. There's the thing in C++. Coroutines in C++ 20. unless 23 introduced some stuff that I'm not aware of, but coroutines was one of the big 4 features of 20. So the way C++ knows to make a function a coroutine is it uses one of the 3 core keywords: co-return, co-yield, and co-await. I'm not too worried about co-yield for this because I don't think we'll need it, but co-return is like, we are done. And then co-await is basically, please suspend me, optionally return, please suspend me and resume me later. So we're going to get those. I'm always co-panicking. Feel free to ask questions because there's quite a lot to go through with coroutines, but it's basically a state machine. That's all it does. All the C++ compiler does is output the machinery for you to transition through the various state machines, and then you are just required to customize certain parts of it so it knows what to do and when effectively. It's just laying out that. So all the stuff about sort of saving off the stack and changing the instruction pointer and the stack pointer and all that, that's all done for you. All you have to do is just provide a few customization points. You can throw with an exception. I probably won't fully integrate that today because, as always, it's more work than you think, but I will show what that means. Okay, so basically what I'm writing now fundamentally will not work. What I like to do when I'm kind of stepping through this and reminding myself is one of those times I'll actually let the compiler errors guide me, because it does kind of help you build up the story of what you want to do. So this is... Right, this is a simple coroutine, okay? It does no more than a regular function, but it is a coroutine, and that's kind of the most important thing. So here, actually, I'll try and use clangd where possible, but I'll just build this first just to get us going. The errors are actually not too bad in telling you what you need to do. So this one here is like, this one's hopefully reasonably obvious what you need to do. It's like, you need the coroutine header. It's like, sure, I'll include the library for the language feature. Sure. It should work now, right? So now we need to, again, this function cannot be a coroutine. It's very strict about this. This cannot be a coroutine. It has no member promise type. So promise type is the kind of like the core part of the coroutine. It's the customization point through which the state machine is driven. And what this kind of reifies itself as is you need something like a task, okay? The name, steady. The name is entirely irrelevant. Task is pretty common in the various bits of literature and I don't know, tutorials and stuff. You could call it coroutine. It really doesn't matter, but you have to return a task, okay? You have to return a thing, and the reason you have to return a thing is because you need this promise type, and this is the first weirdness. And I'm prepared to be corrected here. I don't think this kind of customization is done anywhere else in the language. You have to create a struct with this specific name, cased exactly like that. It will not work unless you have a promise type like this, which I think is a little bit strange, and I've not seen it anywhere else in the language where you have to provide something of a very specific name and casing. Yes, this is all state machine. It's just all state machine under the hood. We're just going to be running through it. Indeed. So now it's going to be like, oh ho ho, you haven't told me how any of this works. So within promise type, we have to provide functions of a very specific name and shape in order to drive the state machine. And this is what it does. So basically, the first thing is going to be like initial suspend. Okay. So this is the first function we need to do. And this is what the machinery will call when you first create the coroutine. At this point here, this line here creates the coroutine, and it's like, do you want it suspended or do you want it to run? I.e., as soon as you create it, do you want to run through the code or do you want it to start in a suspended state? So you have the choice of which one you want, and sometimes these are returned to like lazy or eager coroutines. I've seen them referred to as hot and cold coroutines. It doesn't really matter. I want mine to always start. So I will return a special object. So it gets a little bit weird. I will return a special suspend never. Have I misspelled this? I think I will return a special object this is known as an awaitable, and we can get into that later. But this is a special object which basically says, hey, don't start in a suspended state. At this point of this invocation, you may start executing the code. And now it's like, final suspend. So again, yes, you're right. You might be able to you have to have this scope, so you have to use task : promise type. Basically, you probably could use a using alias. Yes, I've only ever done it as an internal struct, but you would still have to have this structure somewhere. You could probably potentially rename it and have a different name and call using. That is a good point. Okay, so then the next thing is like final suspend. Okay, like what do you want to do when it's like after this call? What state do you want it to be in? Like, do you want it to be finished, or do you want it to be suspended? And actually, this time, you want it to always be suspended, because at some point I'm going to have to retrieve this value from the coroutine. So this leaves it in a suspended state, and this needs to be non-throwing. So this needs to be the other side part. This needs to be no except, because. Oh, good. Some great puns going on here. Okay, yeah, I've not really looked at state execution, so perhaps it does. Yeah. So this function will get called by the I will use the phrase the machinery quite a lot. So the machinery will call this basically at the end here to say you are done. What state do you want it to be left in? And at this point, your last chance to dance has gone. You cannot throw an exception. If you throw an exception anywhere within the coroutine, you can in theory catch it, but at this point you cannot throw an exception, so this is why it has to be marked as no except. Okay, and then we have auto return object int now. It's very important to know. Return object does not return an object. Why would it? This function is called on a co-return with this value. So this allows us to capture this value and persist it to be used later on. So that's why I've called this int x here. It doesn't really matter what you call it. If you returned a string here, you could have a string here. If you returned a whatever, you could template it if you were feeling particularly templatey. But yeah, it would be better named set return object or store return object, but it just means this is called on the return object. It does not do the returning. So this is a struct, right? So I can just be like int value, and then I can just be like save that for later. Might need that. Spoiler alert. Might need that. And then we have get return. Sorry, I just saw this in the error. Get return object is the thing that is called that produces the final task object. So remember what this function returns. What this function returns is a task. So somewhere within the machinery, you have to like, how do you want to make that task? So here we can return task, but we also have to, somewhat confusingly, persist the coroutine handle. I made a mistake somewhere. Someone's pointing something out. Return value, not return object per line 34. Oh yeah, return value, thank you. My previous comment still stands. Return value does not return a value. It captures the return value. Get return object is the thing that will produce the thing that this function will return. And because it's a coroutine, there's this concept within the language called coroutine handle, which is this lightweight handle to the internal mechanism, and that is what you call resume on. If you wanted to resume this, that is what you would call. So outside of this task, we're going to need to store a coroutine handle templated on the promise type. Everyone still out there? So we'll store this handle. so we'll need to return a task, okay? But the fun part is that the point we are called, we are within this constructed promise type, okay, which is templated here. So we need to get we need to get our coroutine handle through some mechanism and store it here, and that is obviously with stored coroutine handle promise type. Okay, from promise this. Obviously, like how is that not intuitive? Because this will call construct this object and pass this into this. So we are just going to kind of do the coroutine handle dance and kind of reach in and out and shake it all about, and then we end up with the handle. And then the final one, which I'm going to kind of ignore for now, is auto unhandled exception. Just going to do nothing. So unhandled exception will get called for us by the machinery if an exception is thrown anywhere where it could be, and then from here you can do like stood. Is it get current exception? And then you could persist this here, and then later on you could choose to stood rethrow. I think it's stood rethrow. Is this an actual stood promise under the hood? No, this is totally different to stood like promise. Do you talk about like package task and async and that? Those are totally separate. What a great question. Like, is there a reason there isn't a generic templated task type provided by the standard library? As far as I'm aware, I don't know why not. My understanding was because this was quite a big feature, and this was already going out with quite a lot of other big features in 20, because this was alongside ranges and concepts and modules. I think they wanted to get the language feature out and hope that the library would catch up later, but I think we've agreed on C++26 and there's been no new library stuff. So unfortunately, other than like generator, I think you're kind of on your own. But I don't know. This is fun, right? So this is the machinery needed to do this, and then we can call F here, and then obviously to get out the object. So if we want to return this, okay, then we just do F. Bring this up a bit. F dot handle, right? Dot promise dot value. Actually, it's 42, obviously. So you can kind of see how this works, right? We have a task object. We go through the handle, get the allocated promise, because this is dynamic. This is heap allocated, dynamically allocated. This will be heap allocated for us. And then from that, because it's all templated, it knows it has this method and we can call that. Easy. We're storing the handle into the variable handle instruct. We are constructing it with the handle, because it's kind of weird. The machinery knows that there's a promise type within struct, but it still needs to ask the promise type how to construct the outer object, presumably to give you a chance to persist this. It is, like I say, I think Coroutines is very strange in terms of a lot of like the design decision and customization. It makes a lot of sense when you kind of get your head around it. Like it does make sense, and I'm not saying I could come up with anything better, but it took me quite a few goes at writing this. Like previously, I've been playing around Coroutines for a couple of years now. It took me when I first sat down quite a few goes to kind of wrap my head around it. Okay, so that passed. So we got the value out. So there's actually a memory leak here. Exciting, which I could not construct this. So I wrote this earlier, and I could not get the CRT debugger memory leak checker to pick up on this. But there's 100% a memory leak here, and all you have to do is, if the handle is valid, then you have to handle dot, I think it's destroy, because so this promise type object is dynamically allocated, it's nude, and then in here this is where I call the subsequent delete. This is not an RAI wrapper, presumably because of the lifetime. Like if you want to suspend at the end to introspect the value, then at what point do you release it? So I think that's why. So we just wrap it up into R types to destroy at the end. So that should still work. Fun though. So the co-return keyword calls the get return object. Effectively, I try not to think of it as like calling that. I more like it signals to the machinery that must then be called to return that. It's not, yeah, but yeah, you can think of it as calling that. It's like this eventually boils down to a call to this, which returns this, which we capture here, which we then mess around with. So yeah, that's fun. So basically done, right? Ship it. Fix our memory leaks. Yeah, so rule of 5. What I will do is now that I'm kind of hopefully showcased some of the mechanics of it, I will start moving this into proper files. We make this a task, encapsulate it. We'll disable the copying because we don't want to accidentally double destroy it, and we'll make it move only and do the gubbins around that. So that's going to be the next start, is to kind of like weaponize this a little bit. But I just wanted to kind of, in like a super quick high level, like 20 minutes in and out coroutines, just kind of go through what we wanted to do. Potentially, I don't really know what the code says. Like I am kind of happy writing this kind of code, so I'm happy to do it. I find it kind of fun as well, which I guess is, you know, it's a hobby. There should be some enjoyment in it. But yeah, not everyone would probably want to sit down and write this. I think Boost's got a pretty good coroutine library, and it kind of works with ASIO if you need like a context loop, like an event loop to drive it, whereas we're going to have to drive our own kind of event loop, because the whole point of coroutines, right, is that you suspend it and then you do other work while that's suspended. But like, what's other work, and how does that driven, and how do you get back to the original thing once it's done? So we're going to have to kind of lay the foundations for all that. It's really not, I don't think it's going to be a lot of code. So yeah, let's start fleshing this out. So I'm gonna source scheduler. Have I typed that right? Yes. And then I'm gonna do vs source scheduler task.h once namespace game, and then we're just going to take 45, take all this d45 cheat, slap that in there, make that class. Bob's your uncle, thanks your aunt. There we go. You're right, gonna need that. Stick that in there, and then hopefully, so just for now, we should be able to hash include scheduler task, and then this should become game.task. Actually, let's just keep that as a struct just for a second, just to check this is all wired up correctly. All I'm doing is just moving that, nothing fancy, just moving that to a new file. Yeah, great question. So what's a good case for coroutine? I think, like, do you mean in sort of like the broader sense of software engineering when we use coroutines? Because like you've got async in C# and Python, and those are kind of good examples of when you potentially are blocked on something, but you want to continue doing meaningful work until you're resumed. So waiting on socket IO, waiting on a timer, waiting on a file IO. What I want to do is basically make a bunch of the systems into coroutines and allow them the autonomy to schedule themselves and kind of say how long they need to be waited on before they're resumed. So I guess the non-coroutine way of doing it would be to have a bunch of functions which do, like, I don't know, say we had update graphics and update physics. Okay, you might want the graphics to run as fast as possible, but you might want the physics to run every 16 milliseconds, right? So every 60th of a second. There is some machinery required in order to do that. Something has to maintain like a timer and this list of functions and call them. All the function does itself. It calls it and it doesn't do anything until that amount of time has lapsed. What I want to do is set up a framework that handles all that, and then just any system can be like, call me on the next frame, call me in 2 frames, call me every 3 frames, call me every 10 milliseconds. It's not a new problem to solve. I just want to solve it in a slightly different way. So hopefully that kind of makes sense. You need something to drive the coroutine, because you have to remember, coroutines are entirely, in any language, are orthogonal to threads. They are orthogonal concepts. Right? You can combine them, and I'll show I might be able to show kind of, hopefully by the end of this you might be able to see how that would work in this system. But coroutines is just a way of having resumable functions driven by a loop that basically says, you should be resumed, you should be resumed, you should be resumed. That's kind of it, and it allows better utilization of that single thread. I think, async is just a keyword that a lot of languages use to kind of invoke this magic, right? You'll see, hopefully it makes sense. Like, I'm going to just keep writing code and hopefully it all kind of starts to make sense. But do shout questions as we go along. I suspect there'll be a lot of questions, and if I miss yours, I apologise. So what I'm going to do now is I'm going to make it so that we no longer return an object. I am not, in my mind, because I've got a rough idea of what I want the architecture of this to look like, coroutines won't return values. I just want to keep it simple. Like, if I schedule a task, which is the renderer, that doesn't return anything. It keeps just scheduling itself until someone tells it to exit. I mean, everything has an overhead. I believe because these are stackless rather than stack full coroutines, the impact is quite negligible, and it doesn't involve a thread context switch, because again, this will all be single threaded. This will just be a way of time. We will just be effectively time slicing our own single thread. Yeah, I think it hopefully become a little bit less abstract as we kind of go through it all. How long do you think it'll be before you've caught up on the series? I mean, this is stream 59, so whatever number you are, n 59 minus n, that's how far you've got left to go. How far has the series got left to go? I've been saying this for about a month now. I think we're about halfway. So keep all this, and then basically, so here we can just do return. There's a second like special function we can just do, like return void, which basically says our coroutines are not going to return anything, which is fine. Also, I'm going to start making some changes as we go along. What I'm now trying to do is come up with this concept of like a schedulable. Each stream is about 2 hours, roughly. Sometimes we go a bit over, but each stream is about 2 hours. I want to create these tasks. Is now going to become a thing that we can kind of schedule. So we will say, hey, go onto the schedule and start running this task. So I want these to actually start off suspended. Okay, I want these to start off suspended because I don't want the code to when we say create the renderer task, I don't want to immediately start running because it will just block. I won't be able to do anything else. I need it to go into the machinery of the scheduler, and then at some point the scheduler will pick it up and resume it for its go, its spin on the carousel. So this is all the same. This is all the same. Don't need that anymore. We do now need a coroutine handle, promise type handle, handle. This is just, I've had to add this so this can still work because it's now a class, so it won't, because it's no longer a struct, you cannot just aggregate initialize it. I've made a mistake somewhere there, that should have that, and then, okay, let's format this. I don't know why my tooling's not caught up, it's a little bit sad, but we'll fix that in a second. So this is all that has to be public because it needs access to it. This is all public. Probably make this constructor private, but I don't. Probably for the best, actually. Okay. And then I just want to do some simple task const task equals delete auto operator equals. It's kind of I don't want people copying this around, but I will allow moving. Other equal. So for this, what do I want to do? I need to steal the resources of other. So I'm going to have something like what? Handle stud exchange other dot handle. So you can stick a null pointer in a handle and it will invalidate it. So this will take the other handle, stick it in ours, and then stick a 0 in the other one. The reason for the private constructor is because no one should be constructing task other than the promise type, right? There will be points where we have access to a coroutine handle, like just through the machinery, and I just want to prevent myself more than anyone accidentally sticking that in a task and confusing things. This is the factory method, if you will, through which the tasks are created, and I want to keep that within the friendship, within the sort of scope. Yes, they're stackless, these, so you can only co-await up one to the previous one. You can't do like a deep await. Effectively, yes, yeah, that's a good way of thinking about it. Okay, so we've got that, and then I think that's, and then we just have to do. Oh, hang on. Do this. Do this, that, and the other. So now we just have to be. This is the classic issue. Is that whilst we're moving something into us, we're assigning it, so we may already own a thing. So we just have to make sure that we get rid of that. So I think the way I normally do this is to stud ranges swap handle other dot handle return this. So we're given a task that we are transferring ownership from, we're moving from, so this is probably going to be an X value, but it could be, it'll be an R value. So if we swap its handle for ours, we get hold of the new thing, and then the other one, which if it's been moved from, you shouldn't be using anyway, eventually we'll get out of scope and do the cleanup for us. So this is kind of just a little trick you can do to kind of make the state management a little bit easier. I just have to remember to do it for every member that we have, or write a swap method and just call that once. So just something to be aware of. Stud ranges swap means you don't have to do the using namespace stud double step trick to make sure to sort of appease the ADL gods and to make sure you find the right ranges. This uses something called a CPO, customization point object, and it does what you think it does. It does what you think it should do. Yeah, exactly. ADL issues with that. It's kind of a nuanced bit of C++ that. I would just say if you're writing modern code, use stud ranges swap and don't worry about it. Okay, I think we're kind of there now. So again, that's just a bunch of boilerplate. The thing to do now is we want to write the scheduler, which allows us to put tasks in. Argument-dependent lookup. It's a weird curio of C++ that I think was needed way back in the day, and it allows you to reach into the namespace of the arguments as part of function resolution. It sounds kind of strange, but it makes some parts of the language work, but not everyone likes it, and it's a little bit confusing and can sometimes be unexpected. Whereas this uses CPO, which inhibits ADL, but still gives you the right outcome. Sometimes called like Koenig lookup. Anyway, all right, let's write it. Let's write scheduler. Yeah, the language is very much going more functional, which I think is great. I think if you can decompose your program down into like pure functions that just take inputs and produce an outputs with like no side effects, I think you're on the way to kind of testable and composable code. It's a very lofty kind of goal, but I think it's something we should be shooting for. Let's create a scheduler. Prahama. Okay. Scheduler. So I'm going to sort of first define the API, and then we'll have a think about how to implement it. So we're going to want a queue of tasks. The idea is that we will add things to the queue, and then the scheduler will just run until that queue is drained. And at each tick, it will resume everything in that queue, but that task itself might reschedule itself if it's like, oh, I'm not done yet. Can you please reschedule me in the next frame, the next 2 frames, the next 10 frames, the next 20 milliseconds, etc., etc. Thinking about this, I would normally use a queue. However, I'm almost certain we're going to need to iterate through things for the rescheduling, so I'm actually just probably going to use a deck, which would be the data structure underpinning a stood queue anyway. I just want to be able to see the internals. Scheduler task. Okay, so we're going to have stood deck of task queue. What's up? Hello, good morning. Also, I didn't realize Cookie Monster was here. Hello, glad you're here. Hope you're enjoying it. I believe, correct me if I'm wrong, I believe Cookie Monster was the author of the GTA San Andreas bug article, which is pretty cool. Temperature's good, fan's good. What am I doing? I'm going to schedule a task. So I want to do something like auto add. I want to add a task, right? Insert in queue. I don't know. Pick your favorite verb. I'm probably going to go with add. We'll pass it by value because they're lightweight anyway, and we're going to be transferring ownership. So I'm going to stood move it into the queue anyway. So that's pretty simple. And then we're going to do auto run. So we're going to add tasks and then we're going to run. And the point when we do run, that's when the game starts. Yeah, people complain about this a lot, and I'm not really sure how to fix it. I'm not an audio engineer, but also they have a lot of background noise. I have a very small office, so the PC fans, I have a fan on in here just to keep cool. I could try lowering the noise gate, but my concern is that it would then allow too much background noise in. So I don't really know, unless I can just pump in like a very low level amount of white noise. I'm really unsure how to fix it. I could try adding the noise suppressor, but I don't know. No, the scheduler itself will be responsible for removing tasks. Once you put it in, like be pretty sure you want it to be scheduled because it's going to get scheduled. The source scheduler CP hash include scheduler.h. Let me just bring this across. Otherwise, I risk my big bald dome getting in the way. Auto scheduler task void. I'll have a task, please. Scheduler. No, we're not going to do threading, at least not to start with. I don't think we'll need it. But indeed, why not allow? Well, I'll tell you what, why don't we do this live? You can tell me how it goes. Filters, noise gate. Forever, remember, I'm on minus 77. So I want to lower that, right? I want to make it higher. Is that better or worse? I'm on minus 35. Do it live. How's the silence? Deafening? It's exactly the same. Okay, fine. In which case, 77 it is, and back to the code. Can't tell if outstanding. Maybe at the beginning, maybe at the end of the stream, we'll fuck around with the settings. Just have to get used to the silence. Okay, so q dot push front stood move task. So you're going to keep the things you go to the front of the queue, right? That makes sense. And then we'll execute them front to back. Yeah, it doesn't have a threshold. It has ranges, and then it has like attack and stuff like that. Okay, fine. Is what it is. Maybe I'll just get, now that's what I call white noise, and just play it in the background. Okay. So let's just. Also, I don't want to destroy out too much noise, because how else will you enjoy the dulcet tones of my clickety-clackety keyboard? Scripting, scheduler, copy, source, I don't know, okay, utils will do, utils, cmake to source scheduler, eSource scheduler cmake, and then this will be scheduler.cp. See if that blends. Yes, indeed. I cannot spell, so I will unfortunately have US keycaps, which is nothing against the layout, it's just not what I'm used to. And I did have to pay about 25% of the keyboards to have it shipped here. And I've done that twice now because I realised I wanted the second one after I brought the first one, so I've only got myself to blame. But it's around Monday, which is exciting. I'll yeet this one into the sea. Okay, so that's I think there was a question: arbitrary decision to avoid copying when putting in the queue. I think it's just just good manners, really. Well, actually, no, sorry, no, that's a lie. The task itself is non-copyable, so I can only move it. I can only transfer ownership of it into here. Like, taking it by value, I can either construct it in line via PR value, or I can still move it in via an X value, if you want. If you want all the values. Indeed, yes. It's going to get warm next week. And I'm traveling a lot for work next week, which is exciting. Okay, so run. While queue is not empty, auto top equals queue dot front. Okay, get the front of the queue, and then I'm going to want to, right, okay, let's go back to the task here. I'm going to need some sort of helper method, so let's do, oh, cheeky. Explicit operator bool const return handle and handle dot done. Okay, so this will basically tell us whether the coroutine is finished or not. Okay, whether we've called resume and it has exited, i.e., it's not suspended waiting to be resumed. So if top, in fact, actually, I'm gonna hash include error. I'm going to assert that expect top bad task in queue. QUE. The tasks should always be resumable because we're going to strip them out later. Is task polymorphic? No, task is not polymorphic. We will not be deriving from it. So I'm going to expect that top always be. Does it not like? Because it's implicit. We can fix any problem by just adding more exclamation marks. So I'm just going to expect is my assert, right? So I'm going to assert that this is always a resumable task. I would posit that something's gone wrong if there's anything in the queue that shouldn't be. And then if top. Oh no, we don't need that then, do we? So then we can just do auto resume void handle dot resume. Okay, so this is once you've got a coroutine handle, you can call resume on it, which will then, from this function call, will jump into the coroutine at the point where it's suspended. That's how you transfer factory control flow back. So if we call top.resume, okay, we will call into that suspended function at that point. And then we should be able to do queue dot top front. All right, let's just get it off the queue. So again, there's no rescheduling, there's no going on, like this is one and done at the moment. Like we will, and again, we'll go back and we'll test it and we'll try and convince ourselves that it works, and then we'll expand on it. So let's go back to our tests. So yes, as I was saying earlier, you could template task on the return value. However, I'm positing at the moment that all tasks do not return a value, so we will not be able to co-return a thing. I've kind of taken that functionality away. I did it to start with because I think it's easier to show what's going on, but as you'll see when we kind of get into the implementation, I don't think we're going to need it. He says, famously, and then frantically spends the last 20 minutes of the stream retrofitting that functionality back. But here we are. Hello, hello, hello. Welcome. Okay, so what we should be able to do now is get our set. Oh, not that. Absolutely. Whatever you do, don't do that. Heat's getting to me. Can't type. Scheduler. So scheduler is pretty lightweight. So auto shed equals game scheduler. Okay. And then I will do shed.add foo. So again, this is why we need the coroutine to start suspended, because if this was suspend never, then when you call this, it would then go and run this code, which is not what we want. We want it will be suspended, go into the scheduler. The scheduler will then pick it up and it will then resume it because it is suspended. So it is undefined behavior to resume an unresumable coroutine. This will resume it and it pop it off and execute it. So this should run, but let's just check. This should run but not do anything. We need to construct some methodology for us testing this. Exactly, yeah. Good numbers today. Over 100 on YouTube and nearly 50 on Twitch. Hello, welcome if you're new. I'm going to be bashing my head against some reasonably advanced C++ today, but I'm going to try and explain everything as I go along. You're more than welcome to ask questions. And join the Discord, indeed, and then ask more questions there. Because I'll hang around after I finish melting in my little sweat locker. I will probably hang around on Discord with a beer. Okay. Oh, that beer's sounding pretty sweet right about now. Okay, so this should. Ooh. What have I done wrong? A? I said everything a priori to this with such confidence. Yes, there's actual experts. There's people who actually know what they're doing on Discord rather than me who's kind of flailing around. A? Also, I don't think I've ever really tried this on MSVC. I've only really done it on Clang and GCC, so I should have prefaced that. Oh, I should have mentioned that early on. Is it that? Yes. I want to. Hang on, I think I've got my predicate wrong. What is this trying to say? This is no. I want this to say yes. I want this to be can resume. Okay, as in, I wonder if operator board is not really the. Let's be more explicit because I think it's can resume. So I can resume if I have a handle and I'm not done. So this should be expect top dot can resume. Good spot. Good spot. Yes. I do want to get a bigger monitor, I'm just saying. I do want to go like ultra widescreen, curved, like wrap around my head, just fully immerse myself. Okay, so we need to kind of convince ourselves that this is doing a thing, like just because the test pass is not necessarily a good indicator that anything useful has happened. So probably want some sort of side effect to this. Can I... I'm not sure if I can do this. This would be fun. cannot remember if you can have a lambda as a... Oh, do I have to probably state what it returns? It's like the USB drive, right? You gotta get it wrong 4 times, even though there's only 2 possible combinations before you get it right. Cannot convert argument from scheduler task lambda 1 to game task. Yes, you're right. I do need to invoke it. Thank you. Good spot. So what we can do here is we can have auto done. you should be up here. Don't know what I'm doing. Oh, you can't do a lambda capture with members, can you? I really want it to have a side effect. That's it. You can't have a coroutine which captures with a member capture list by reference. Oh, but MSVC will let you do it. That's hilarious. Is it just because I've not used it yet? No, I don't really want something hot strapped to my head whilst I'm coding. So what we should be able to do now is assert false done, okay, and then assert true done. So the idea being here is that although we've invoked this coroutine, it has not executed because it's gone to the scheduler, and the scheduler will then run it, exit, and then call it. So I'm hoping this can kind of convince us it's doing what we want it to do. Nailed it. Okay, so this is our basic scheduler, right? So let's change foo. Okay, because we're not using foo anymore. I might have to do this in a lambda. Okay, let's do... Let's do simple await. So what I want to do is have something like this. So let's get rid of this. Let's get rid of this. Don't format that. Okay. So this is a function, okay? It's just going to run. This is kind of might be what you have in some sort of component that you want to repeatedly schedule, right? You'd have an infinite loop, like the renderer is just going to keep going until something says it should exit, right? And in this case, like if x equals 5. I know you could do this with a for loop, but I'm trying to showcase this is how I'm thinking about it in my mind, how we'd actually use this. Like x equals 5 is like I've received the stop message, so I'm going to quit the renderer. So what I want to do is co-await, right? I want to say I will await on something, okay, and then I'll resume. So this will keep going. It will pause here, and it'll go round, and it'll pause here, and it'll go round, then it'll pause here, and it'll go round. There's kind of two bits we're missing to this. One is the, as it says there, the expression. We have to await on a thing, and that thing allows us to do the customization. Secondly, we need to update the scheduler to kind of take account for this. So the idea is that when it gets here, we basically might not want to call resume every single time, okay? We might want to say, oh, you've asked to be waited on some number of things. So let's start writing some more. Let's write some more code. What's the code say? I'm going to see if I remember how to do all this. Scheduler wait.h. Okay. So an awaitable has 3 special methods that you have to implement with a very specific name. Again, it doesn't matter what you call this, but it has to expose 3 methods. And the awaitable drives the machinery for pausing and resuming functions. And I'm just going to double check because I do have the docs for coroutine handle just up here, just to remind myself some of the runes, because I can never remember them all. Where is it? Okay. Oh, right. Here we go. Here. Nailed it. Okay, so auto. Wait, ready? Ball. Turn false. This is called when you immediately suspend a coroutine through the await mechanism. Lots of words. When you suspend the coroutine through the await, so when I call co-await, it will try and suspend this coroutine. It will immediately call await ready, and this is like an early out. It's like the thing, because you're going to be waiting on something to happen, right? You're going to be waiting on socket IO or file IO or a timer to pass, right? If you know that thing is already done, then you can return true here, and then it will just fall through. So it's an optimization, which we don't need because we will always be relying on the scheduler to kind of resume for us. All right, suspend. So this is called at the point suspend. It's past tense. It's not suspended, it was suspend. So this will be called for us. What's the return type of this? I don't think it's void. This will be called for us at the point it is suspended. So when the machinery goes through and suspends the coroutine, it will suspend it, and then it will call this and say, here is the suspended coroutine. So this H will be the equivalent of the handle within the task. I think that's right. I think that's right. So this allows us to persist that and effectively redo whatever we need to do. And then you finally got await resume. So this is when something resumes the coroutine, right? Because it won't be so once you've awaited, you lost control, right? Something else has to resume you, which is why you have to have a scheduler, right? You have to have something that the code can drop out into and keep going and eventually resume you. When it does call handle.resume, it is the call is someone else's responsibility, right? That's why we have to have a scheduler, because you have succeeded execution. Yeah, again, but what we can do is we can pack information into the wait such that the thing that's resuming us knows when to do it. So we'll basically tag in like a number of frames that have to have passed, or a timer, or something like that. So that's kind of the goal. And then await resume is called when we are done, and we can return, because it's auto type, we can return whatever we want, and then that will pop out of the co-await if we wanted to return something. So again, if you were waiting on network traffic, once your event loop or whatever has, you're using poll or select or IOUing or whatever it is, once that said, oh yeah, here's some IO, it will call resume, and then await resume be like, oh, I've got that data now, pop it up, and then you basically be like, so you could do something like const auto message equals co-await blah. It will suspend there, and then it will resume with the data that you wanted. But we're going to keep it simple. So basically, what do we want to wait on? I think is the big question. Is that what fundamentally are we waiting on? I can think of 3 things that we want to wait on. Like we want to wait to have happened before we resume execution. Some number of ticks. So hey, please resume me in 5 frames or 2 frames or probably 1 frame. So I imagine each thing will be like, unless it needs something special, it'll be like, just call me on the next frame, just call me on the next frame, just call me on the next frame. Time, please call me in 200 milliseconds, 16 milliseconds, 12. Pick your favorite number of milliseconds, it should support it. And then the other thing is other tasks. So you could imagine that we want to fan out some work, and actually I cannot continue until these 5 subtasks are done. So hey, can I please co-wait on these 5 tasks? Those will go into the scheduler, those will get executed, and then once those are done, we pop out. That's slightly more nuanced, and I think we can probably get there today. I don't know, but that's where we want to go to. So those are the 3 things that I think we want to wait on. So let's just start building it out. Let's just write that as with all this stuff. We just got to start writing some code. So std unit 32 t ticks. Okay. So I'm going to do this probably the simplest one first because it doesn't involve any timing or anything like that. I don't have to use the chrono. Wait ticks. Okay. So we could. So yeah, that's the other thing, is we could have some sort of functional predicate that returns true when it wants to, and we might end up abstracting that. I think it's easier to conceptualize this now with something more concrete. But yeah, that's another alternative to doing it. Because the reason I want to do it this way is because I want to remove the bookkeeping logic. I don't want every function that wants to schedule itself on a timer to have to worry about keeping track of the time. It should just be able to say await n milliseconds and it does it. Whereas if you had a predicate, you would have to presumably take a snapshot of the time and then periodically poll that function and allow it to check the state. So for now, we're keeping it super simple, and we can build on the complexity later. But the goal is to shift bookkeeping complexity to just the scheduler, so we can just be like, hey, next 3 ticks, whatever. Yeah, this question comes up a lot, like where to start reverse engineering. I always say, like, you will probably need to learn or be familiar with some sort of low-level systems language like C or C++. I would definitely recommend trying to learn a little bit of C and then write some C and then pull it apart in Godbolt, Binger, Ghidra, whatever, something that will give you the assembly, and then try and in your head reify how code becomes assembly, and then once you kind of figure out how it goes one way, it becomes slightly easier to figure out how to do it the other way. What am I doing? What am I doing with my life? So I'm bringing the scheduler wait in. So because this has hopefully the correct runes, we should be able to await game wait 3u. Expression result on use, that doesn't seem right. What does the actual compiler say? Scheduler tests 5. Oh, that'll do it. Turns out, don't know what I'm doing. Yeah, okay, fine. Okay, so this will construct all this misery, suspend the coroutine, and then store this. So the problem now is this needs to have some concept of checking whether the thing that's been pushed in has like a wait condition, and then checking it, and then only we need to basically conditionally call resume. Okay, at the moment we call it every tick. But we need a way of conditionally doing that. What we're doing, we're trying to write a coroutine based job scheduler for our game. So I guess we could start off with just doing the easy bit, which is tick count. Scheduler. Scheduler. So that'd be Q, and then tick count. And then what's gonna happen is I think this then needs to have for const auto task in queue. So I'm just going to refactor this slightly so it makes sense, so the tick count kind of makes more sense. So we're going to go one pass through all the tasks, right? So each of those kind of get their time slice. Okay. And then we'll do at the end tick count. And then we need to do q dot erase stood. Get some ranges in there. Ranges. Remove if q const auto e return not e can resume. All right, I think that's right. What are all the bloody runes for this? Stood ranges end q. Yes, that's why I'm removing it. Sorry, good spot. I meant to remove that. Because basically I'm going to go through all the tasks and then remove them all, which is why I removed that, and then we'll update the tick count. So that way each thing has kind of, it's more consistent. Yeah, that was a good spot. Why is it not like this? No, actually, have I erased wrong? It takes 2 iterators, doesn't it? Doesn't it take... Oh, I bet I can't use ranges. I bet I can't use that. I bet, and then I've got to do it the miserable old school way. Boo. Let's just close that so I can see what's going on. Okay. Great. Okay, so again, it's kind of 2 passes through it, but I'm really not that fussed. So when we add a task, that will go into, I think what we need to do is basically, we're going to need our own struct wait task now, okay, which will have in it a task and a std uint32t tick target, okay, because that's what we're going to try and get to. In fact, actually, so I'm kind of, I had a rough idea of how this was going to work, but I'm now kind of figuring out a lot of the implementation details as I go along. So I hope you're still all out there. This is how I think. So a task may or may not have a tick target, right? It might be single shot, one and done, just run it on the next tick, or it might have this concept that it needs to be rescheduled in some number of ticks. We're going to get over 4 billion ticks. I'll go through and change. We could change that in a minute. Yeah, it probably should be size T. Why would we need to make the deck of a deck of unique pointers? Because we're not using polymorphism, and deck's stable, isn't it, on insert, because of the way it does the sort of mini fixed arrays inside it. So I don't think we'll get invalidation by adding more tasks. Not that I think we're holding references outside of it anyway. Okay. So now back to scheduler. Fix this up. Optional. Stood. Not. Okay. Okay, so now this is nice because it's modern C++. We can do task tick target. And then basically, I think we're going to if tick target and tick count. Actually, I'm gonna do this internally because I think this will make, because I want to do const auto t equal. What am I doing? I want to expect tick target is less than or equal, no, is, oh, we're going to get this the wrong way around, is greater than or equal to tick count. Basically, what I'm trying to do is check that it's not run away from us, we've missed it. So the tick target should always be in the future. So if I'm on tick 5 and I say please run me in 5, so that'll be on 10, the target should always be greater or equal to that. If it goes the other way, then we've missed it. So then we can just do if tick target equals tick count. Okay, so we've hit that. Then task.resume. This might get a little bit messy, but I think we can tidy up later. Else, like, so basically, if we haven't got a tick target, then we want to be called on the next one, so just call that. Else, resume it. I might put some logging in here just so we can see what's going on. I'm still not quite sure exactly how to fully test this. A voyage of discovery for us all. So let's do debug. So schedule tick count. Oh no, so that's an excellent point. I want the awaitable to be in terms of a delta, so please wait me n ticks, but when we wire this all up in here, we will add the current tick count to that, so it'll be that many plus the future. But again, I don't want the caller to have to worry about that, because that sounds like a nightmare. Like, hey scheduler, what tick count are you on? I guess I'll add 3. So we will handle that internally, but it's a good point. That's why I've called it tick target rather than the task where it's called like wait tick or whatever I called it. I've already forgotten what I called it. In the awaitable, I called it wait ticks. So then that's a delta, whereas this is an absolute. Okay. Okay. So now the final piece of the puzzle. So I guess there's a design decision we have to make as well now, is whether we make the scheduler global or whether we pass it around, because it's the awaitable. So let's go back to our test. Like this here, this, and then we'll need to know about the scheduler. So do we pass that in? I'm thinking yes. I don't really want a global scheduler. I don't want a singleton, because that, one, is a pain to test, and 2, would prevent us potentially from scaling it to multiple threads if needed. I'd rather just sort of suck it up. So hoping I'm not going to end up with a circular dependency here. And then this will take scheduler. Got to be careful about, very careful about lifetimes here, because coroutines are notorious for getting away from you with the lifetimes because you're suspended. I think that's fine, and I think we basically, like, not great. No, I think that's actually right. I think that's fine. I think the scheduler, no, the scheduler will be fine because it's going to live outside of this anyway because we're passing it in. That's fine. I don't know what I'm talking about. Okay, so here, I guess actually what we could do is we could just be like game scheduler. Because we're invoking the lambda, we can pass in whatever we want. Okay, that's fine. That's appeased the LSP anyway. Oh, great spot. Absolutely amazing spot there. I would have absolutely missed that and then been incredibly grumpy in about 5 minutes time. I've been trying to explain how this is going to be useful for the last hour and a half, and I've probably not won the hearts and minds of many people yet. I think the proof will be in the pudding, and if we can advance this to a point where people can start seeing the usefulness of it, then I'm hoping it's just a way of abstracting the machinery of just running tasks over and over again, where some of them might want to delay how often they run. That is true. I'm out of water. Oh no. It's going to get really, really warm now. Unusual join activity on the Discord. I'm sure it's fine. Let me just... AC might be on it. He's already resolved it. Didn't even to look. Nailed it. Okay, so over here we basically want to say something like what am I doing? So where's the scheduler? We're going to need a reschedule. So basically, I've been suspended. Now reschedule me with this delta. Stirred coroutine handle stirred uint 32t wait ticks. Okay, hopefully that API there makes sense. We're basically going to say, here is a handle to a coroutine that presumably you know about. Okay, it'd be weird if it wasn't. Please, let's start again. At the point you call co-await, it will suspend the coroutine. The machine you will call await suspend. Yes, remember at this point we have been called. Dot resume has been called in the scheduler. Okay. So absolutely not that one. It's gonna make things worse. Resume has been called. So at this point it's going to get removed. Okay. However, it's gone through the co-await. It's called await suspend, okay, and then wait, and so now this won't be removed. However, we don't want it to execute on the next tick because we now need to wait on something. So we need to just modify the queue just a little bit, just a little modification to the queue to allow this machinery to kick in. Okay, I'm sure we're all all on the same page now. Okay, so what we need to do now is we need to find our task. So I'm going to have to... I don't want to expose the handle. Also, note, we could remove it, but the handle here is templated. But most of the time you get it back non-templated because you cannot know a priori at this point the internal promise type. So is handle is for handle for like I don't really like that. Coroutine handle. I want to like return handle equals handle. Is handle's not right because I'm not checking the identity of the object. I'm like, has handle? Is this, yeah, is for this task? No, not for, is this task? Yeah. Gross. So now we should be able to do const auto task equals stud ranges find if handle const auto e return oh Jesus e dot is this task? I'm an existential nightmare. I'm probably gonna want to actually search something in that, aren't I? Cute. Okay. Okay. Stud get. Oh no, it's not. It's not cheaper, is it? E dot task dot is this task? Because you have to remember we're storing a wait task struct now. I do like to use all the modern features. So now we got the task, so we can expect task not to equal stud ranges cend nope q could not find task. This absolutely does not want to be const. So then we should be able to do task dot what? There you go. Task dot tick target. Oh, wait a minute, what am I doing? Ugh. Task tick target equals wait ticks plus tick count. Okay, hopefully that's the bit that rectifies the steady the delta with the absolute. So we're going to say, hey, we're now rescheduling ourselves. So again, we've resumed ourselves. We've got into the co-await. We've now been suspended again. The awaitable, the wait object is called back into us to reschedule us to set the tick count, so we won't be deleted, and then we'll keep going through happily. We happy? Think it's going to work? I need to obviously construct some sort of test for it, but it's just a lot of the problem with coroutines is that when you're setting up the machinery, it's just a lot of bouncing around because functions have functions can pause and resume, and it's kind of driving what's going on. Yes, no, in that order. Nice. Okay. Scheduler 57. Oh, it's because it's now e dot task, isn't it? Same issue we had before. Yeah, it probably is a little bit of overkill. Like I said, this is I think I was really honest at the beginning. This is a little bit self-indulgent. The whole point of this series is to write only the code we need to make a game. However, I've allowed myself a few small indulgences, and this is one of them. This could be a total disaster, and we'll just throw it away and we'll just use a for loop and some callbacks. But for now, I think this is fun. Windows Internal is what's the book you want by what's his face? Ionescu. You want Windows Internals by Alexander Ionescu. That is, and others et al. That is like the book on the Windows Internals. I really should get myself a copy, actually. I don't seem to have one. Okay, so let's go back to the test. So hopefully this doesn't spin indefinitely. And we see... Nice, okay, so we got the 5 ticks. Oh, actually, no, that didn't quite work, did it? Because that should be 3 in the future each time. So where have we gone wrong. I was expecting to see more than that. A lot of these logs I think we can probably turn into some sort of side effect that we can then assert on, but for now, log, debug, go wait. Oh, do I actually? I'm surprised that will... Oh, I know exactly why that works, because we've not rescheduled it. So the problem here is that we're co-awaiting, but this is never getting rescheduled, so it's just going to resume it and call back round. I'm surprised it didn't crash actually, but hey ho. So now we should be able to do scheduler.reschedule h wait ticks. Okay. Helps if you call the code that you wrote. I bet I didn't namespace it. I bet I didn't namespace it. Nope. Ah, there we go. Okay, so look, now you can see it calls co-await, and then it waits 3 ticks, and then it gets resumed, and then it waits 3 ticks, and then it gets resumed, then it waits 3 ticks, and gets resumed. So that is the scheduling code there. You can basically say, please run me in n ticks. Coroutines can be nested, but you always return to the caller. You can't go more than one call stack deep, so you would have to make sure that you're kind of cognizant of that as you go down. It's not what's called stack full coroutines, where you can basically have like 20 functions deep and call await, and then it just like shifts your whole stack out. There are some nuances to calling them in depth. So actually, so what if we then do -1? It is entirely a state machine. Like the whole thing is built as a state machine, and all you do is provide the various obtuse customization points to drive that state machine and to tell the language, the machinery, how to move between the various transitions. So that's pretty cool. So we call await, then we wait 1, and then we wait 2, and then we wait 3, and then we wait 4, and then we wait 5. So hopefully, like that is it. If you want to just do it at this very basic level, so hopefully that kind of makes sense. Like I'm pretty pleased with that. I think I've got more to do today. We're not going to finish just yet, but hopefully that kind of makes sense. Yes, the whole thing has does one dynamic allocation which sets up your stack and your registers. You can, in promise type, you can provide a custom new and delete operator within that if you don't want to use dynamic allocation, you want to do it from a pool. But yeah, effectively it allocates a bunch of state, and then which is enough state for it to basically pause and resume it by just copying registers over and moving the instruction pointer and the stack pointer. I was just trying to think, like, can we add another task which does oh wait, so if this gets called every tick, right? I'm just trying to think if I can construct a test. Convulsion became a member. Thank you very much. Much appreciated. I'm just trying to find, I'd like to actually have a test for this. Oh, very much. So fibers are stack full, whatever they call the big boy coroutine. They are coroutines, but they're the ones that allow you to just suspend at any point in the call stack. They're much heavier weight, but they are a little bit more flexible. This is, I guess, a lighter version of that, but you can consider them kind of two different implementations of the same concept. So that I've just done the same. So you should get co82. So co81 tick. Is that right? I don't feel that's right. I feel there should be more space between them. What have I done wrong? Also, oh no, wait a minute. There's the gap is getting bigger. So 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2. Oh, hang on, what's so it resumes both of them. Then it comes back around the top. It's increased the tick count. Just need to filter the co-weights from the ticks. Well, right, okay, fine. So what I'm going to do is I'm going to remove this. And then what I'm going to do here is have a vector string. And then we're going to have auto log equals std vector std string. And then we'll pass into this log, and then we'll do delete that log dot. One thing we could do actually in the future is actually have this return, say, like the delta time or the delta tick, so that when you're resumed, you know how much time has been passed. I mean, you could probably infer it from that, but that might be kind of useful. Anyway, I'm getting ahead of myself. Log dot pushback co-await 1. Log, and then my ClangD's crashed. Let's give it up. So auto expected equals std vector std string. I'm trying to figure out what I want. So it should be co await 2. Because that was pushed on last, so that'll get executed first. And then, so this is gonna, it's gonna execute both, go round, won't remove them because they're both suspended, come back round. This will be scheduled for one frame time. So this should. Oh, it's going to check schedule 2 first because it's the front. I wonder if I should switch these the way around. Schedule 2 is going to be on the next frame, so that will execute. As will coroutine 1. Then it's going to come out around 2. So this is now going to be scheduled 2 in front. So I think this is where we then end up doing this. When do we end? 1 or 2. Yes, is that right? Should be const. Take that for free. Assert equal log expected. Have I stopped too soon? We got 2, and the 2, and the 1 and the 2, then the 1, 1, and the 2, and then the 2. It doesn't. I feel like I'm. Let's make this simpler. Let's make this always run as 2U. So this should run every frame, and then this other one should run every other frame. So 2, 1, 1, 2, 1, 1, 2, 1, 2, 2. They should both run 5, 6 times. Yes, one does finish before 2. Yes, you're right. So it should run for the extra tick. So you should get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think that's right. Oh, is it not going to format my code now? Because Clang D is... Why is it... That works, and I'll give Vim a kick. Yeah, there's a bang GitHub command, I think. We could run that for... That'd be grand. Okay, nice. There you go. Okay. Stud deck queue. Hopefully that kind of makes sense. Like, this is what I wanted to get to. So now, really, the code can just do whatever it wants, and it can just basically say, please schedule me and whatever. So I think the next thing to do is add the timer. So we should be able to schedule ourselves in, say, 10, 20, whatever milliseconds. Simple await. Tick. Well, but like, we don't need threads, right? Because this will just make the most of that single thread we have. However, what? Let's see if... What is interesting, though, is that you could have a scheduler per thread, right? And reschedule could just put that on any thread. and then the scheduler will pick it up and resume it. Yeah, I've done the same. I've tried to hand roll fibers with assembly, and it's a massive pain. So yeah, there's no so to make this multi-threaded, we would have a thread pool. Each thread would have a scheduler, one of these objects running on it with this loop, and well, probably not until it's empty, probably until it was signaled, and then the reschedule method would just find a thread, take a lock, push it in the queue, release the lock, or use some lock-free queue, whatever, doesn't matter. Both you can see how this does kind of scale outwards, because you're just posting work for people for something to do, and then you're basically saying when it should do it, and the functions themselves will just quietly will just suspend and resume themselves as needed. It's just schedulers all around. We just need an abstract factory I scheduler, and then we're done. I think we might have a quick look at. Let's comment this up first, because I've done quite a lot. And it's gone. Scheduler. Actually, this is now just everything, isn't it? Add scheduler class and tests. Okay. So back to the wait. We could have different wait objects, or we could just have a variant which stores whatever things we want to do. I'm tempted by the variant because I just think it would make life maybe a little bit easier, and in fact actually we might end up being able to abstract a bunch of this into potentially some sort of lambda anyway. Yeah, there's stood chrono. So that's what we'll use. So let's do that. Let's do the path of least resistance, because it's easy just to smash more code into this than we need to. And then that into that, and then variant. So stood variant stood uint 32t stood chrono. I think nanoseconds is the highest fidelity we're going to get, I think, because as everyone knows, the Windows file time is 100 nanosecond intervals since the 1st of January 1601 or whatever it is. Well, indeed, yes. It's what I want. Is it steady? Is it steady clock for timing things? I always forget. Wait time, and that becomes time. In fact, actually, I'm gonna be a little bit more explicit so we don't accidentally do a cast. So now when we get to here, I'm just gonna do if const auto v equals std, is it get if unit h2t wait object is it by pointer? Yeah, okay. I'm going to tidy this up later, I just wanted to kind of get going with it. Okay, so that won't work because we now need to go and add the reschedule method, the other one. Scheduler. Okay, so now we can basically, the idea here is we just reschedule on whatever we need to reschedule. So this might be in future, like, I don't know, another task or whatever. Std chrono nanoseconds wait time. Add that, and then I think we're gonna. I'm just gonna slap another variant in here for now. Std chrono nanoseconds targets. We need the Ronto and Quecto ratios. Okay, so let's go to scheduler. Take this. So we fix this up. So what's it not going to look like? It's not going to like this. This now becomes target equals that, and then sit this in here, and then I guess also the scheduler is needs to keep account of std chrono. Is it steady clock we want or system clock? I always forget which one it is. I want steady clock. Elapsed. There's loads of clocks now. Yeah, let's keep adding more clocks. Elapsed. Oh, anything. Did I don't want a clock, do I? I want a time point. I think. Oh, actually, no, hang on. What am I doing? Just keep track of it. It's how many nanoseconds have elapsed, right? That's true. That's the easiest way. So then target becomes wait time plus elapsed. Again, we await in terms of a delta, but we convert that into the absolute internally. Like, oh, I want to wait 500 milliseconds. I don't want to wait until 1500 milliseconds has elapsed or whatever. I just want to wait for this amount of time, and then it goes and does it. So if we have a tick target, Then we're going to need to do pretty much the same as the other one we did. Const auto star v equals std get if std uint32t star tick target. If we get that, then do that. Ugh. Oop, hold on. Okay. One of my favorite series of tokens. Else console v chrono nanoseconds, if that. So then expect v is greater than or equal to elapsed if v. So now actually because we don't know how long each frame is going to take. As soon as it is past that, so as soon as v, hang on, I'll get this right around. So that'll be in the future. So as soon as elapsed is greater or equal to v, then we'll run it. And there's nothing to check in on that. And then, okay, hang on. I have to, at the beginning of each tick, const auto now equals what stood chrono steady clock now. And then here we do elapsed plus equals stood chrono steady clock now minus. I'm going to change. Already decided I don't like the name of that. Start. Okay, so we're going to accumulate time as we're doing each set round of tasks, and then when we upgrade the tick count, we'll also update the elapsed time. This is a little bit messy. I think we can probably tie this up later. I just want to kind of just check that this is working first. So hopefully, again, this kind of makes sense. It's very much the same thing. We're just saying, hey, have you told us that we need to reschedule you later, and has that thing come to be? Let's do schedule tests. So let's do time. Should include chrono. Hash. Nope. Using namespace stood literals. Just want to just drive this once. So this should just do log starting co-await wait scheduler 500 milliseconds, half a second. Oh, that's not a logging function, is it? Log dot I just wanted to see if the test does actually pause there. I'm trying to build like a simple job scheduler using C++ coroutines. Left of... We check that. But hopefully now, if this works, you can start to see the advantage of this. So you can have your infinite render, you have your infinite loop of like physics, and be like, hey, just call me again in 60 milliseconds. Just call me again in 60 milliseconds. Hopefully this is where it starts to kind of all coalesce. The syntax might be a little bit grim. What was it not like about that? Its previous local declaration. Are you sure I can't do that? That? Interesting. I thought that scoped it to the if block. It shouldn't. No, const is fine because I'm not. Modifying it. No, it's definitely like the following warning is treated as an error. Declaration of v hides previous local declaration. Yeah, but my understanding of this was introduced in C++17, this scoped if, where you could have an expression at the end which would evaluate, and basically I thought the v was only valid in that. It's just kind of mad that that's not. Is that a bug? I've got codes. Look, it says failed in red. I really don't want to waste any time on this, so for the sake of making progress, because I think we might be able to tidy a lot of this up later anyway. Reverse Hungarian notation here. I have to look that up. I don't think that's right. I'll have to have a look in a second. Wasn't it like about this? Looks like it's here. What have I? Where have I goofed? It should implicitly cast the milliseconds to nanoseconds because it doesn't lose precision. Oh, yeah, well done. Good spot. Glad someone's paying attention. I think that maybe a bit more of an aggressive time. Let's do 5 seconds. Just want to see it happening. Then I'll be reasonably convinced it works. One elephant, 2 elephant, 3 elephant, 4 elephant, 5 elephant. Okay, we got time scheduling, which is pretty cool. I need to come up with some sort of test for this, probably with a logger. Maybe if log puts in a timestamp. It does. Oh yeah, good point. I wonder if you can get that out in the test. That hey, if I run for at least this amount of time. But that's. I mean, there's a bit of boilerplate, but actually, like, it's really not a lot of code. Do you know what I mean? Like, this, we're going to tidy this up because it's pretty gross. But really, it's just a case of checking some conditions and calling resume. Task is pretty slim, and wait is pretty slim. It's not actually a lot of code. It is indeed. Wait on. I'd be interested to know people's thoughts. Like, does that... I'm stopping coding here, but now I'm happy to chat for a bit. Stream 59. Like, what's people's thoughts? They think that's good system? Bad? Can anyone see the vision? Can anyone not see the vision? Indeed, 10 away. Yeah, I mean, the whole point is that also then we should be able to fan out. So next stream, we'll add the ability to wait on another task and maybe multiple tasks. Because I think that'll just tie it all together, write a few tests, bish bash bosh, smash it out, do that in an hour-ish. And then we'll go through and we'll take the renderer and the Lua level and we'll create those into systems, components, whatever you call it, things that you can wait on, and we'll schedule those to start with. And then we'll just see how it all fits in with each other. The other thing to handle is exceptions at some point, but that's not too bad. I think it's just a bit of boilerplate, and then you want to basically rethrow it out of the run command, basically. Yes, I mean, we should always remain skeptical of new ideas, especially anything I think is a good idea, because I just like using all the new toys. I think it'd be good, and I think it will scale in future when we want to do a bigger project, like an FPS or something like that. I think we should be able to lift and shift that and relatively easily spin out some multiple threads. But really, like, Coroutines is not a lot of code, but it is just a bunch of weird boilerplate that you have to kind of get through. Oh, before everyone disappears, I've fixed the YouTube gifting, so if we want to roll the dice... Outstanding. YouTube allows me to gift 5 members a month in block. Oh, so 10 members a month in blocks of 5. So that's 1 month of channel membership. You get access to some behind the scenes stuff. There's a secret Discord room that you're more than welcome to come along to. You get early access to videos. I will be fully transparent. There is a chance that within that 3 month I will not produce another video because it takes me so long. This may be just my attempt to encourage people to continue it afterwards, or not, but we'll see. Harand has been the benefactor of 2 of these now, so he's slowly hoovering them all up for himself. Yeah, cool, excellent. I am melting. I need to go and get. Oh, actually, there's a few people on the Twitches. Let's see if there's anyone worth raiding. Hold on 1 moment, caller. Is anyone doing C++s? Same category. Oh, it's not looking good. Not looking good. C++ is very underrepresented on Twitch. Oh, I'm really scraping the bottom of the barrel now. Oh, hang on, someone just popped up. Who are they? GPU programming, day 22, C++, OpenGL, Vulkan, DirectX, and DirectX 12. 4 viewers. Let's do that. I don't know what they're doing. Oh, they are currently not there. So, oh well, what are you gonna do? Brilliant. Anyway, I hope everyone enjoyed that. I'm gonna hang around on Discord for a bit. I'm happy to answer questions on this because I get it's a little bit obtuse. Next stream we'll do some more, and then we'll get back to doing some game programming. Thanks very much. I will see you all on Wednesday. Have a good one.